Welcome to this explainer. Have you ever just stopped and wondered, what is actually making things in the world around you pull together or push apart, without anything even physically touching them? Well, we are about to embark on a journey exploring the invisible forces that literally shape interactions in our physical space. Based on Physical Science Unit 01, Lesson 06, we're going to decode the hard evidence behind electric and magnetic fields. We are talking about forces that act over a distance. It's kind of like having a special lens to detect the invisible pushes and pulls happening right in front of us. So, get ready to see these everyday interactions in a completely new way.
Okay, let's look at our roadmap for today. We'll be covering Section 1, What is a field? Section 2, Attraction and repulsion. Section 3, Visualizing field patterns. Section 4, the electromagnet test. Section 5, Reasoning from observations. And finally, Section 6, Summary.
Section 1. What is a field? To really grasp our physical world, we have to bridge this gap between the things we can physically touch and the things that interact across totally empty space. So, what is a field? It's essentially an invisible area of influence around an object. It helps us understand exactly how a force can act on something without making direct physical contact. I mean, think about when a magnet snaps onto your refrigerator door from an inch away. Or, when a balloon makes your hair stand straight up without even rubbing against it. You're witnessing the direct result of a field. That force bridges the gap, and tracking that evidence is exactly how scientists prove these fields are really there.
Section 2. Attraction and repulsion.
Let's start with a massive question that scientists have to answer. How can we prove a magnetic or electric field exists if we can't actually see it? This is the core of our whole investigation today. If a force is entirely invisible, we can't just take someone's word for it, right? We have to look for observable reactions. We have to look at what happens to the objects that get caught inside that invisible area. Keep this idea, this search for physical proof, right in the front of your mind as we move forward.
Now, to find that proof, we need to know what we're dealing with. We're focusing on two distinct types of fields here. First up, electric fields. These are created by electric charges, which come in two types, positive and negative. Second, we have magnetic fields. These are created by magnets, which also have two distinct ends, but we call them poles, specifically the North Pole and the South Pole. So while they both create these invisible areas of force, the actual sources of those forces are different. Regardless of whether we're dealing with electric charges or magnetic poles, there is a fundamental, unbreakable rule that governs how they interact. Opposites attract, meaning they pull together, and likes repel, meaning they push apart. If you bring a positive charge near a negative charge, they're going to pull toward each other. But if you bring two north poles of a magnet together, they will forcefully push each other away. This invisible pushing and pulling, that's the primary evidence we use to confirm that a field is actively working in that space.
Section 3. Visualizing field patterns. Let's walk through exactly how scientists turn these raw observations into hard facts using an evidence-to-claim example. Picture a simple bar magnet sitting on a table. If we sprinkle tiny pieces of iron filings, all around it, those filings don't just sit there randomly. No way! They instantly snap into these distinct, beautiful curved lines looping from one end of the magnet to the other. That is our first piece of evidence. The second piece of evidence? The iron filings cluster incredibly densely right at the very ends of the magnet. From these two visual clues, we can make a really solid scientific claim. The invisible magnetic field has a specific structured shape, and the field is absolutely strongest at the poles, which is exactly where the filings are packed the tightest.
Actually, let's pause for a quick misconception check, because this trips up a lot of people. A major misconception is that a field only exists if there is another object nearby to react to it. That's entirely false. Even if a magnet is floating in the completely empty vacuum of deep space, its magnetic field is still there, stretching out invisibly. The field exists totally independent of whether we can see it pulling on something. Another really common misconception is that electric and magnetic fields are just two different words for the exact same thing. While they are closely related and they can affect one another, they are distinct forces. You can absolutely have a static electric charge that has no magnetic field at all.
Section 4. The electromagnet test.
So we know how to find evidence of a field around a permanent magnet, but what happens when we create a magnet using electricity? How does an electromagnet test provide evidence of a field? This is such an incredible way to observe how manipulating one variable gives us completely different physical evidence. We aren't just observing a rock we dug out of the ground anymore, we are engineering a field and watching how it behaves.
An electromagnet is usually made by just wrapping copper wire around an iron nail and hooking the ends of that wire to a battery. The truly beautiful thing about an electromagnet is that we can change its variables. If we wrap more coils of wire around the nail, the magnetic field gets stronger. If we use a higher voltage battery, the field gets stronger. And how do we know for sure the field is stronger? Well, we use observational evidence. A stronger electromagnet is going to pick up a significantly greater number of paper clips. Those paper clips act as our field evidence, proving that our changes actually worked.
Let's contrast these two sources of magnetic fields for a second. On one side, we have static, or permanent magnets. Think of your classic horseshoe magnet. Its field is always there, always active, and the strength of that field is consistent. You can't just flip a switch and turn it off. On the other side, we have electromagnets. These require an active electric current to produce a magnetic field. The literal second you disconnect that battery, the field disappears and all the paper clips drop. Because you control the current, you can adjust the strength of the field or turn it completely off, which gives you massive control over the invisible forces at play.
Section 5. Reasoning from observations.
This entire process is really about reasoning from our observations. Scientists map the unseen by carefully placing test objects into a space and just watching how they react. If you take a compass and slowly move it around a magnet, the compass needle will change direction, perfectly tracing the invisible field lines. By mapping exactly where the needle points and how forcefully it snaps into position, scientists can draw a highly accurate map of a force they can't even see. The physical movement of the test object, that's the hard evidence. And we experience this evidence in super practical ways every single day. When you take off a sweater in the winter and static electricity causes your hair to stand straight up, those individual hairs are actually repelling each other due to an electric field. When you go hiking and use a compass, that tiny needle is reacting to the massive, invisible magnetic field generated by the Earth's core. And every single time a magnet forcefully pulls itself out of your fingers and snaps onto the refrigerator, you are directly feeling the power of a field transferring force across a gap.
Section 6. Summary.
Bringing the whole shebang together, our core objective today was to use evidence to explain that electric and magnetic fields exist and exert forces on objects without touching. And you now know that while these fields are totally invisible, their effects are highly measurable. We can track them using iron filings, we can manipulate them by building electromagnets with batteries and wire, and we can prove their existence just by watching how objects either attract or repel one another in physical space.
So as you go about your day today, I want you to think about the unseen environment you're walking through. What invisible fields are silently pushing and pulling on the world around you right this very second? From the Earth's magnetic pull keeping our compasses aligned to the static charges on your clothes, the universe is endlessly active with these unseen forces. Keep your eyes open for the evidence, keep asking questions, and keep exploring the amazing physical science all around you.